Guys, welcome to today's class where we'll be looking at division of polynomials. So in the last class we looked at multiplication of polynomials and went through a series of procedures and processes. Now, for division of polynomials, it has a particular set of processes just like the multiplication that we actually need to follow through in order to execute it. So for division, there are many things we need to consider first of all. So the first thing we need to consider is that when we are dividing polynomials, is a bit different from when we are dividing rational values or rational functions, rational values basically. So the way we divide polynomials, we actually need to consider four terms. The first term I want us to consider is the polynomial itself. The second term is the divisor. The third term is the remainder, and the fourth term is the quotient. First of all, the polynomial itself is the larger polynomial that you are going to be dividing, that you are going to be breaking down. So that is what we call the polynomial. Now, the divisor in this case now becomes the polynomial that you are using to break down the bigger polynomial. That means the smaller polynomial in this case. That's what we call the divisor. And then we also have what we call the remainder. So the remainder is what is remaining after you have actually divided. It's just like a simple case of division of 5 divided by 2. I can easily say, or 5 divided by 2, I can easily say 5 divided by 3. Let's do 5 divided by 3 now. I can say 5 divided by 3 is 1 remainder 2. My 5 in that case, assuming it was a polynomial, we would have called it the polynomial. The 3 that we are dividing it by will be the divisor. That is what we are dividing the polynomial by. Then, the 5 divided by 3 is 1. It can go only once. So that's the quotient. While the remainder will now be the 2 that will be left out after we are done dividing. So we'll take examples on the board and then we'll analyze this process. So first of all, for division of polynomials, when we talk about division of polynomials, we look at a function, a polynomial. We consider polynomial f of x that are dividing by a divisor. Let's call this g of x. We get a quotient, that is the value we get, and then a remainder. Okay, let me say this r. We call this q, call this d, we call this the p. So from this analysis, I can tell you that my quotient multiplied by my divisor plus the remainder will give me my polynomial, which also gives me which is my f of x. So what do I mean in this sense? I use the analogy of 5 divided by 3. What was I trying to tell you? I was trying to tell you that when you divide 5 by 3, where 5 in this case is regarded as the polynomial, and then the 3 in this case is regarded as the divisor, we get a value of 1 remainder 2. In such a way that the 1 here is regarded as the quotient, that is the value you get after dividing, and then the 2 here is what remains. That's why we call it the remainder. So if you look at this analogy very well, you realize that if I multiply the divisor, quotient and the divisor, that is the quotient and the divisor. What the quotient here is 1, the divisor is 3. So if I say 1 times 3 plus, what is my remainder here? The remainder here is 2. What does it give me? I have 3 plus 2, which ultimately gives me 5, of which 5 here will be our polynomial here. So this analogy explains this principle. So this principle is a common principle we use when we are looking at division of polynomials. So in the next, let's take an example now to actually understand this process. Now we have an example here. We have divide polynomial f of x by g of x, where f of x is equals to 5x squared plus 3x minus 7, and then g of x is equals to x plus 2. So when we want to divide polynomial, we actually use a method of long division that we actually know from our younger days. I think in the basic school, you know, when you want to divide the value, you have f of x. You have f of x to be 5x cubed, 5x squared, and then we have g of x to be x plus 2. Because they told you are dividing f of x by g of x, it means f of x is the polynomial we're using here. This is the polynomial we're dividing, while g of x in this case is the divisor. So we have the polynomial and we have the divisor. Since we have this, we can now do what we need to do. So now, from our knowledge of long division, I'll create a table and I put my f of x, that is I put the polynomial in here, the larger one, and then I put my divisor outside the polynomial. Now, how do I now start? The first thing I do is I take the first value I have here, that is the variable. I have x, I divide my 5x squared by x. That is, I say x in 5x squared. That is the first value here in the first value here. X in 5x squared here will give me 5x. That's 5x. After getting that, I can say, after I've gotten the first one, it's a very simple process. You divide the first one by the first one. The answer you get, you use to multiply everything in the divisor side. And I'll say 5x times x, I have 5x squared. 5x times 2, I have 10x. Then I subtract. I'll subtract this whole thing here from here to here, minus from here to here. So 5x squared minus 5x squared, that gives me 0. Then I have 3x minus 10x. That gives me 7. That gives me minus 7x. Because 3x minus 10x gives me minus 7x. Then what do? I bring down the minus 7 here. And then I have minus 7x minus 7. Then I do the same thing I did in the first place. I divide this first value by the first one I have here. So x in minus 7x will give me minus 7. Then I use that minus 7 to multiply everything here. So doing that, I will have minus 7 times x, I will have minus 7x. Then I have minus 7 times plus 2. That's minus 14. Now I can now subtract again. By subtraction, I know minus 7x minus 7x will give me 0 again. Then I have minus 7 minus minus 14. That is minus 7 minus minus 14. I know minus and minus will gives me plus. And I know 14 minus 7 is 7. So I can easily just put here plus 7. So in short, I can remove the zeros since I know they're not useful. I can say, so therefore, since I've gotten this, I can now say confidently. I say, therefore, the one up here is known as my quotient. This is my divisor, and this is my remainder. So I can tell you that was, therefore, f of x divided by g of x, which is 5x squared plus 3x minus 7 divided by x plus 2 will give us what? Will give us 5x minus 7, which is the quotient, remainder 7. So that is the process of division of polynomials. So in order to even prove the principle that we're given, you can actually now say, to prove now, just so we're convinced, remember that was the quotient times divisor plus remainder must always give us our polynomial. So in order to test that, we know our quotient here is 5x minus 7 times the divisor, which is x plus 2, plus the remainder 7. Let's see if it will actually give us our polynomial, that is the f of x. So what do we have here? Multiplying this, we have, for multiplication of polynomials that we have done, we know we multiply this by everything here. So 5x times x, we have 5x squared. 5x times 2, we have plus 10x. Minus 7 times x, we have minus 7x. Minus 7 times 2, we have minus 14, then plus 7. By solving, by simplifying, we have 5x squared plus 10x. 10x minus 7x, that gives us 3x. 7 minus 14 gives us minus 7. And this brings us back to our f of x. So we have proven this. So this is the concept of division of polynomial. In the next class, we'll be looking at another example on how we actually divide polynomials without actually making any errors and then getting your answer precisely and concisely. See you next class.